Hello everyone, welcome back to another episode in my Unity Open World series. So in our vaulting system we have a problem. We have defined our vault position in the middle of the wall. So because of that, if I try to jump from an edge of the wall, it first come to the middle and then do the jump. So if the wall is quite long like this, it would be a problem. See? So character always come to the middle. So yeah, I'm going to solve this problem in this. So after solving the problem, it would be like this. If I try to do word here, it will do the word right there without trying to come back to the middle of the wall. It will do right then and there, like this. And this episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me. So in the current version of the vaulting system, if I press a space button while I am in an edge of the wall like this, it first come to the center and do the jumping. So actually instead of doing that, it would be better if the character do the jump from that point without coming to the center. So the reason is, like, let's say if this vaultable wall is like this, then it would be a problem. Let me show you. Now it's okay because see, it always come to the center. So how to fix that? So in order to fix that, we should get the closest point to the character along this wall, actually along the wall in the land position, sorry, not the land position, the jump position. Why does it become black? Looks like a bug. Okay, so what should we do to fix it? Right, let's open the vaultable script. And yeah, okay, so here when we get the vault point, what we return is the vault point or the jump point. So I think I should have used jump point here because here it is jump position, or maybe we should go to the prefab and change the name so it would be easier. Let's call it vault point. Right, that's better. Now yeah, we return that location of the vault point, but the issue is now in the character, when I do the vault, now where is that function? Okay, when I do the vault, okay, it happens here. We send the vault point voltable get volt point to the character moments volt point. Now here let me delete this unused lines. Now here we do the we have the transform volt point like this. So this is originally the volt point transform that we had from the prefab. Now here we need to change its position to the closest point of the character. So how to do that? So in order to move the character to the closest position, we need to figure out the closest position on the wall. So for that we can use this formula. Assuming S is the closest position, S equals P plus lambda S into Q minus lambda S times Q minus P. So lambda S is represented with this formula. So yeah, I'm not going to explain this formula here. So if you want, you can study it here, but I'm going to use this formula to my code. So how to do that? So define that function. I think I need another class. Let's call it math helper. It doesn't have to be a mono behavior. And here let's define public static vector. Why we can't use vector? Maybe we have to use in Unity. Oh, nothing is happening once I remove the mono behavior. Okay, anyway, let's keep it as a mono behavior. Let's define public static vector. Why can't we return a vector? Anyway, let me define vector 3. Public vector 3 get closest point and input would also be two vectors. No, transform T and vector 3 point P. I'm still not sure why I don't get suggestions here. Should be static. Right, then we need to implement that function. So right, the suggestions are working after I restarted the editor. Now right, okay, and now we need 2 points on this object. Blue one is forward vector and the red one is right vector. No, red one is the forward vector. Yeah, no, blue one is the forward vector, red one is the right vector. So okay, so we need 2 points. Let's take P vector 3 P equals T dot position, and vector 3, oh, this is, no, let's consider this as X, because according to this diagram, X is the player's current location. Let's take it as Q equals T dot position plus T dot right vector into, let's say, 5. Okay, and now lambda float, let's say K, because I don't know how to type lambda in the keyboard, so let's take it as K. So according to this formula, I'm going to take lambda s as K. Then K equals X minus P dot, no, oh, we need to get the dot products, so vector 3 dot, first one is X minus P, and the next one is Q minus P divided by vector 3 dot dot Q minus P into dot Q minus P. Is that correct? That's what this formula says. Q minus P dot Q minus P. Okay, let's hope it is correct. And then right now we know the K, so now let's consider only this solution. S equals P plus lambda S Q minus P, because it will always be this case for us, because only when the character is within this range, only when the character is within the boundaries of the object, the player will collide. So the closest point, vector 3 closest, equals to P plus K multiplied by Q minus P, and return closest. Now we can use this function in the character moment. Yeah. Let's set the world point dot position with math helper get closest point the world point and current character location. That should be transform dot position. Shall we see if this works? No, it's not. It doesn't look like working. Why is that? Shall we print the word point before and after so that we can see if we get anything? If we get the same result. That's the same. Slightly different, right? 10.7 here, and this is 10.0. Actually, here is the problem. In this wall, this is the forward vector. So, according to the way I have scaled this is the forward vector and this is the right vector. So here I should use forward vector. And also, even though I use I update the world position, but the landing position stays the same. So I need to update the landing position as well. So how to do that? Well, I need to okay, let's see. If the world position is here, then the land position is over there. So that means we need to check them in the world space. Okay, let's stick with the character. That difference is like 0.38. From here to there. Here it's 1.31 and here it's 2 point. So it's like 0.7. Okay, it's like 0.7 distance. So instead of the landing point, I think I need to update the land point position as well. So let's do it like this. The land point equals the world point dot position plus the world point right vector into 0.7 f. But dot position here. But here we're gonna have to consider the direction characters entering as well, but let's see that later. Let's see if this works. Let's start jumping from a point like this. Okay, it is working, but it will not work if I try to jump from this way. See, it's not working. So how to fix that? Right, here instead of the right vector of the world point, we should consider this. Transform dot position minus the world point dot position normalized. Let's see if that works. No, I need to revert these things. Now it should work. Right, now I should be able to jump from this way as well. Alright. Okay. Cool. Now the character can jump from any point without going to the middle. Cool. So yeah, that's what I wanted to do in this episode, and I'm gonna stop this episode at this point. So if you like to support my work, you can get the membership of my Patreon club. Link would be in the description below. And yeah, I understand that this part is a little bit math heavy, but I'll put the link. No, what you should do is you should search on how to get the closest point to a line from a given point. So that's what you should search if you need to know further about the formula I use. And also let me know if you have any problems in the comments. And thanks for watching. See you in the next episode. Goodbye.